Welcome to this episode of Mr. Lehman's Knowledge Explosion. In Unit 9, Lesson 1, we're going to be talking about the trigonometric ratios. Now, that's a very big word for something very simple. There are three definitions that I need you to know: sine, cosine, and tangent of an angle. Now, the definition of the sine of an angle, in this case we're talking about angle A, is considered the opposite side, which in this case is A, compared to the hypotenuse, which is always the side across from the 90 degrees, which in this case is C. So sine is simply a ratio, or a fraction, that compares the opposite side of an angle, so drawing a cross, over the hypotenuse of that right triangle. Now keep in mind, you're only going to get a hypotenuse if you have a right triangle. So these three trigonometric ratios only work for right triangles. Now, the definition of cosine is the adjacent side. So the adjacent side of angle A would be the side that it is directly next to or connected to that angle A. So that would be B over, again, the hypotenuse of C. That would be the cosine of this particular angle. And then the tangent of this angle A is the opposite side, which you already identified as A, over the adjacent side, which we already identified as B. So A, B, and C represent any number that could ever be on a right triangle, and these three ratios always exist on every right triangle. So we're going to use these definitions to set up ratios and find some missing sides. I'd like to give you a little bit of background information as to where all this comes from. Remember back when we were talking about similar right triangles. Similar triangles means all the angles are the same, but all the sides are in proportion. If you look at my first right triangle, I have a 3, 4, 5 Pythagorean triple, which I then doubled or multiplied all the sides by 2 to get 6, 8, and 10. Or in the third triangle, I multiplied everything by 4 to get a triangle with side lengths of 12, 16, and 20. And while you maybe can't see the grid very well, these are measured exactly out to those units. Well, what somebody figured out a long time ago was that if each of these triangles have sides that are in proportion, then all of these angles down here at the bottom left, we'll call them angle A, all of those angle A's have to be the same. And in fact, there's only one specific number that angle can be if I use sides of 3, 4, and 5. And that specific angle is a 37-degree angle. Now I'm rounding a little bit, it's actually 36 point something, but it's roughly a 37-degree angle. So all of these have to be a 37-degree angle. So this prompted them to play around with all right triangles of all different measurements of sides, and they programmed into your calculator the ratio for every right triangle ever. So what you can do on your calculator is say things like, what is the sine of 37 degrees? And it will tell you that that's a ratio of the opposite side 3 over the hypotenuse of 5, which is roughly 0.6. And it doesn't matter what the side lengths are. If I had used 6 and 8, again, opposite side of 6, so the sine of 37 would have been 6 over the hypotenuse of 10, which is still equal to 0.6. And if I did the same thing on this last big triangle, the sine of 37 would equal 12 over 20, which is 0.6. The fact that this number always comes out for the sine of 37 means I can use that consistent ratio to help me find sides when maybe I didn't know that this side was 12 and I had to figure it out. And that's what I'm going to show you in the next couple examples. So understand, these are just definitions that represent a ratio, but somebody has figured out what the sine, cosine, and tangent of every angle is, and all you have to do is ask your calculator. So first, let's start by just practicing writing the ratios of sine, cosine, and tangent. In this first example, I'm asking you for the sine of x. So I'm looking at angle x. The sine is the opposite side, which in this case is 3, over the hypotenuse, which is always across from 90, so that would be 5. So the sine of this angle x is going to be 3 over 5, and as I just got done telling you, that's going to be a 37-degree angle. There's nothing else it could be. Now when I say the tangent of y, now I'm looking at a different angle, so you have to be very careful with reading your angles. The tangent is the opposite side over the adjacent side written as a fraction. Well, the opposite side of y is when I draw out from y and then I run into 4 is the opposite side, but the side directly connected to y, or the adjacent side, would be 3. So the tangent of y in this diagram is 4 over 3, and we don't write it as 1 1/3. We always leave it as an improper ratio that we could turn into a decimal. Let's take a look at one more example. In this example, I have two sides, 5, 12. It helps if I know my Pythagorean triples. This is a 5, 12, 13. So when I'm asked for the tangent of n, again, tangent's going to be the opposite side over the adjacent side. So I'm going to say that's the opposite side of 5 over the side that's connected to m, which is 12. Now you might think, well, 13 is connected to point M or angle M, but 13 is across from the 90. That's my hypotenuse. So you have to get very good at identifying what's the opposite, the adjacent, and the hypotenuse. So when it asks me for the cosine of n, let's clean this up a little bit. We've changed which angle we're looking at, but cosine is just a definition. Cosine is the adjacent side over the hypotenuse. Well, it depends on the angle. If we're looking at n, the adjacent side to n is now 5, and the hypotenuse we said was 13. So the cosine of n in this diagram would be 5 over 13. So notice in the cosine of n, 5 was the adjacent side, but when we were looking at angle m, the adjacent side was 12. So these are not specific sides all the time. The numbers can change depending on which angle you're looking at, and that's important to keep in mind. So what do I do if I have a problem like this? It says if the sine of a is 5 over 6, then the tangent of a equals what? Well, what I suggest you do is you draw yourself a right triangle and think about what this means. Any of these angles could be A, usually not the right angle we're talking about. So I'm going to call this angle up in the corner A. It says the sine of A is 5 over 6, but I know that the sine is the opposite over the hypotenuse. So if this is what sine of A is, the opposite side of A needs to be 5, because that's my opposite, over my hypotenuse, which needs to be 6, which would be across from the 90. So there's my two sides of the right triangle that I'm going to use. Oops. And I can use those two sides to find the third side. I could simply do a Pythagorean theorem here and say, let's call this x. X squared plus 5 squared equals 6 squared. So x squared plus 25 equals 36. So x squared has to equal 11. X is the square root of 11. So if x is the square root of 11, now I can do my normal what's the tangent of angle A. So tangent is going to be the adjacent side, tangent is going to be the opposite side, 5, over the adjacent side, which in this case is the square root of 11. Now we need to clean this up a little bit. I got to multiply top and bottom by the square root of 11, which is going to get me 5 root 11 over 11. And we're going to leave our answers like that. We're just asking for the fraction that would represent the tangent of angle A in this diagram. So that's how you're going to write the ratios. In the next video, I'll show you how we're going to use this idea of the ratios, and your calculator that somebody has programmed to help us find the missing angles.